Another important type of association between classes or relationship between classes is class inheritance. So here we have an example of a diagram. This is a class diagram. Again, it's very simple. It doesn't show any attributes, but it shows, again, kind of banking and investment situation where you have a system describing all sorts of assets, and checking account and savings account are type of the bank account. The bank account, on the other hand, involves interest items, insurable items, assets, and so forth. So this is concepts deriving from one another, and it just shows that at the runtime, of course, when the bank account is put together, it will contain parts of this and this and this, and likewise all of these parts will be contained inside these objects as well. We already saw some examples of inheritance in our prior presentation, and as we move along through various business requirements which we're going to cover in this course, we will see more and more examples of inheritance. Using UML to represent inheritance or generalization relationship is typically very well accepted by users, so that these concepts can be validated by the user quite nicely. For example, they can spot very easily that, for example, a bond does not any properties associated with real estate. So this it's just quite good way of describing abstract relationships between the concepts in your application. Here's another example of a class diagram which is showing an application which involves using some sort of work schedule. And I value these diagrams that they tell a lot of story about the rules that we should follow when implementing this software. So the work schedule has this association with the time slot. Essentially, work schedule is a collection of time slots, and each time slot has the date, the range of times, and the employee ID. Notice that we also have an employee class in this design, but we do not have a direct association between the employee class and the time slot. And sometimes this would be okay to have a direct association like this, but here the time slot is simply storing employee ID, which is like unique identifier, just a number. So this is not a reference, this is not a pointer in computer memory from the time slot object to employee. This is only a logical identifier of the time slot, that this time slot belongs to a certain employee, right? So this class diagram tells this entire story. And the time slot has calculate pay method, which obviously will be implemented differently for a specific time slot. So here we have a generalization or inheritance which expands the idea of the time slot at the level of pay calculation. Essentially, you can start thinking about this is that we could create instances of weekdays, weekends, and holiday objects and put them as specific types of the time slot in the work schedule. Okay, so there could be a variety of different time slots added to the work schedule, and they vary between the weekday, weekend, holiday, and sick day. And each one of them are capable of providing its own calculate pay day method. So this is very powerful, very expressive way of showing the logic behind this type of design. Also notice that the holiday also includes the calendar type, because apparently there could be also a calendar object in the system which may change because we could choose different calendars for different locales. we can, in different parts of the world, the holiday schedule will be different. And just like we have this specificity of the time slots, which happen to be, like a difference between the weekday and the weekend, we also have two types of employees, the full-time and the part-time, and the employee has ID, name, and the status, which could be full-time, part-time, and consultant. But also we have the part-time type of employee with an hourly rate and the full-time employee with a salary. So again, when the system is running, depending on what kind of employee, for instance, if I would like to run a report for a specific employee for a given period of time, of course, at runtime, the system will choose what kind of employee to create, because here we indicate that there could be these types of employees, and based on the status of an employee, as it's apparently is stored in a database, we can decide what kind of specific employee to create, full-time or part-time. So there's lots of very useful information in the system, and of course in real application, all of these boxes will become an actual software source files with the class definitions in them. Once again, just a quick reminder that a diagram like this, which is a class diagram, does not provide any information about the dynamics of creation of these objects. It doesn't tell us when the work schedule is created, when its time slots are populated, and so forth. That information could be become visible or visualized in other types of diagrams. This could be presented by sequence diagram or activity diagram, for example. And very quick note regarding convention of UML naming classes. Of course, the names of classes are capitalized. You can see the capital letter, the first letter of the name of the class, and also if it's made up of multiple words, then the other words are also capitalized. This is a very standard convention in object-oriented programming languages to give this type of recognition to new data types which these classes represent. And you can see that it's okay to have the data attribute sections or the operation sections empty, but once you start using them optionally, you try to keep these things consistent. So for instance here, if you start showing the operations, you have to have the box in the middle that represents the attributes, but it's okay to have it empty. So there's a clarity about the class name, the data attributes, and the operations present here. Of course, the empty box does not immediately suggest that there are no data attributes. It's just an option in UML to make it more readable. You don't have to provide all of the tedious details. You can just keep that part empty, but the full class diagram with all data attributes and all methods, like I mentioned before, can be used, can be very helpful in terms of putting it down, validating it, and then begin to a process to generate software classes directly from the stored diagram. So that's a good thing to remember. And also, if you want to keep both data attributes and operations empty, like this work schedule, then it's okay just to use a box, because it does not disturb, does not kind of deviate from other types. But here we would like to keep it uniform. So these boxes are empty, but those aren't, so we kind of keep this uniform for clarity and readability of this diagram. And this, of course, is an example of a comment. So the comments are just connected by these dotted lines, and typically having this kind of like earmark designation in their own box view.